Okay, so we haven't made a video. Well, yeah, I did some time ago, but I'm gonna keep this continued. I'm gonna try to at least. So yeah, I had some things for quadratic equations planned up, so I thought that, well, maybe I should prove it first. So, well, the quadratic formula specifically, but yeah, let's. So we're proving the quadratic formula. So let's write our to prove that x is equal to minus b plus or minus the square root of b square minus 4ac upon 2a. Now this is our to proof. Now pf. Okay, now so we start out with a general quadratic equation, ax squared plus bx plus c, well, that looks like c, okay, is equal to 0, a general quadratic equation, right? Okay, now what we do is we multiply both sides by 4a. Let's multiply the entire equation by 4a. Let's do that. Yeah. Okay, so now multiplying these out, we get 4a squared x squared, and why we're doing this is to make this term a perfect square, right? Yeah. So 4 is the smallest perfect square after 1, but yeah, and we need an a, so we get a plus bax, 4bax plus 4ac is equal to 0. Now, okay, so we'll move this to the right hand side. 4a squared x squared plus 4, I'm going to write it as axb equals minus 4ac. Okay. Now, okay, let's recognize something in this, right? Okay, so we have a 4a squared x squared. Well, we can write that as a 2ax whole squared, right? Because if you don't remember, a squared b squared can be written as ab whole squared, right? Okay, so that's what we're using here because this is 2 squared. Okay, yeah. And for this one, okay, so what we're trying to do is make the entire left hand side a perfect square. Okay, cool enough. So okay, let's think about this, right? So a plus b whole quantity squared, we know that this is equal to, well, a squared plus b squared plus 2ab. Now, okay, let's not use, okay, you know what, let's use some different variables here for the examples. Okay, so first we had, let's use m and n. Mn, this is equal to m times n quantity squared. Then, okay, so we are saying m plus n whole squared, this can be written as m squared plus n squared plus 2mn, right? That's a well-known identity and it's quite easy to prove, so I don't think we need to get into that stuff right now, but yeah. Okay, so we have a 2ax whole squared. Let's call that our m, right? Okay, so, well, yes, because this term cannot be written as a perfect square, we're going to consider it the third term in this equation. So let's rewrite this one as, well, let's see. So we have 2mn plus n squared, and we know that addition is commutative, so we can just do that. That's easy enough. So okay, so this term and this term, maybe we can find some relation between them. So okay, this is our m, right? So we have to find, so first we'll factor out a 2 from this. Okay, so let's see, 2ax b. Well, that's easy enough to see, and this is of course equal to minus 4ac. Let's write it out first, right? It's easy enough to see why this is 2, but now it's easy enough to see where m is, so we can say what n is. And of course we're using completing the square, if you're familiar with that technique. 2ax times b. Now b is our n with reference to this, so we should have a plus n squared. No, sorry, plus n squared at the end, but our n is b, so we'll have a plus b squared. But of course we have added a b squared, so we have to, subtract a b squared, if I'm not wrong. Yeah, okay. Minus b squared is minus 4ac. Okay, then of course we have 2ax squared. Okay, so we can write this as 2ax plus b whole squared minus b squared equals minus 4ac. Good enough. Let's move this to the right hand side, and now I think it should be familiar enough to you where I'm going with this. Okay, so we've got the discriminant, right? Well, let's take the square root of both sides, so we get 2x plus b, and of course the square and the square root. Okay, let's just, so this and this cancel out, and this we have here, we should have a plus minus square root of, and this cannot be simplified, right? Yeah, so we'll subtract b from both sides. 2ax equal to minus b plus or minus square root of b squared minus 4ac. And now isolating the x, and of course we're solving for x, right, all along, because, well, that's what we have to prove. So our final result, lo and behold, dividing both sides by 2a, x is equal to minus b plus or minus b squared, square root of b squared minus 4ac, all upon 2a. And ladies and gentlemen, that is what we had to prove. Let's just, right, I think people write like hence, like QED or something, but I don't understand that, so I'm just gonna write hence proved. Yep, there you go. So that's the first part of this video. Second part is, I think, coming up. Yep, that's nice. I like that. Nice.